Okay, so here we have a couple of combination circuits, which means we have a few resistors that are in series, but then we also have resistors that are in parallel with each other. So the first thing that we want to do is find the equivalent resistance, or in other words, the total resistance for this line since it has multiple resistors. Well, 15 plus 8 is 23. So whenever resistors are in series with each other, which means they're on one path, there are no splits or joins in the wire in between them, we just add up the resistance. And then this 25 ohm resistor, that line will have an equivalent resistance of 25 ohms because it's the only thing on that path. Alright, the next thing that we want to do is find our total resistance. So for the circuit, so it'll be these two equivalent resistances that we're looking at. And since they're in parallel, the formula for your total resistance is 1 over your total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over however many R's you have. Alright, so here we only have 2, so I actually type it in like this. I say 1 divided by 1 over 23 plus 1 over 25. And I get a resistance of 11.979. So the way that I rewrite it is like this. Our total resistance is 1 divided by 1 over R1 plus 1 over R2. Anyway, it ends up being a total of 11.979 ohms. And using that, we can actually find our total current. So let me back up really fast. Voltage is equal to current times resistance. Therefore, if we want our current, it will be equal to voltage divided by resistance. Alright, so back to this. We know that we have a total voltage of 9 and a resistance, or a total resistance of 11.979. So we have a total current of 0.751. Okay, so I'll say total current 0.751 amps. And it's going along this way. Well, at this point, it's split into two different paths. So we want to know, okay, what's the current for each path? Well, it's the voltage for each path divided by the resistance. We know we have 9 volts here, and we're going to continue to have 9 volts. So we'll have 9 volts here and here until we run into either a battery or a resistor, something that's going to change the voltage. And then, of course, by the end, we always have 0 volts. Alright, so the current for the first line will be 9 divided by the total resistance of 23, so 0.391. So our current is 0.391 amps. And then the current for the other line will be 9 divided by 25, which is 0.36. Notice that back here, they will join back up together, and 0.36 plus 0.3913 gives us 0.751, which was our total current. Alright, if we want to figure out the voltage used by each resistor, it's going to be our current times our resistance. So we take, for the 25 ohm resistor, our current was 0.36, and we can multiply it by our resistance, which was 25, and we get 9 volts, which makes perfect sense because we had 9 volts going in, we used 9 volts, and now we have 0. It's a little bit trickier when you have two resistors in series with each other. So we have a current of 0.391 times the 15 ohm resistor, so it uses 5.9 volts. And then we have 9 volts at the beginning. We used 5.865, so we should have about 3.13 right here at the 8 ohm resistor, or right, we should have it left at letter E. And then the 8 ohms should use about that much because we end up with 0. Okay, so let's see what the 8 ohms of resistance uses. So our current is 0.391. Current times resistance, and we get 3.13 volts. So we had 9 volts, we used 5.9, we were left with 3.13, we used 3.13, and now we're back at 0. You can actually find the power that each one of these resistors uses by multiplying your voltage times your current. So for the 25 ohm resistor, it used 9 and its current was 0.36, so it actually used 3.24 watts. The other two, let's see, the voltage for the first one was 5.865 times a current of 0.391, so it used 2.29 watts, and our little 8 ohm resistor used 3.13 and had a current of 0.391, so 1.22 watts. Moving on to our next circuit, we have a, 12 volts is our total voltage, and we're going to continue to have 12 volts until we run into something. Notice that we hit this resistor here. Okay. These two resistors, the 15 ohms and the 9 ohms, are in parallel with each other. So to find their equivalent resistance, we're going to have to do the 1 divided by 1 over 15 plus 1 over 9. And we get 5.625 ohms. So we can actually redraw this to make a more simple looking circuit. We had our battery over here and it was 12 volts, and then we have our 10 ohm resistor, which is just hanging out here, and then we have an equivalency of 5.625 ohms for those two resistors in parallel. So we can actually find our total resistance, which I'll write in purple. Total resistance would be 10 plus 5.65, so we get 15.65 ohms. Okay, since we have our total voltage and our total resistance, we can find our total current. Which happens to be 0.768. So we have a current of 0.768 amps. And it's going to continue on like that until there's a split in the wire. Okay, so we want to find out how many volts this 10 ohm resistor is using. So our voltage is our current times our resistance. So 0.768 times 10 will get you 7.68 volts. So we had 12 volts, we used 7.68, and we're going to be left with 4.32 volts. So that is actually how many volts is going into the 15 ohm resistor line and into the 9 ohm resistor line. So we can find their current by taking the voltage that they get, 4.32, and dividing it by their particular resistances. So for the 15 ohm resistor, it's 0.288 amps that are flowing this way. And for the other one, that 4.32 divided by 9, we get 0.48 amps flowing this way. Notice that they meet back up, and if you were to add them together, you get a total of 0.768, which is our total current, which makes sense. Alright, each of these resistors, since we started with 4.32 and by the end of our circuit have 0 volts, we know that they each use 4.32 volts. To find the power, we could take the voltage and multiply it by the current. So for the 10 ohm resistor, it has 7.68 volts that it used, and 0.768 for its current, uses 5.9 watts. For the 15 ohm resistor, its voltage was 4.32. Its current was 0.288. So it used 1.24 watts. And then, last but not least, 4.32 times a current of 0.48 and we get 2.07 watts. Now if we were to add those all up together, so 5.898 plus 1.24 plus 2.07, we get a total power of 9.2. Now if we took our total voltage and multiplied it by our total current, we should get roughly the same number, and we do.